When disaster strikes and life goes extinct on Earth, there's one plant that thrives in the chaos: the fern.
These ancient household plants have outlived the dinosaurs and about 99% of all life on Earth.
And today we're sharing the secrets of this ultimate survivor. And trust us, these super ferns, they're everywhere.
From the misty forests of the Pacific Northwest to the wetlands of South Florida, even in the cracks of city sidewalks. Thumbs up if you've got a potted fern in your house right now.
See, they're everywhere. They're taking over again. To understand what makes ferns unstoppable, we need to travel back in time to the single worst day in Earth's history.
Picture this, a warm spring day, 66 million years ago. Towering forests, flowering plants, dinosaurs just living their best lives.
Then boom, an asteroid the size of a mountain just slams into Earth and really ruins things.
In a flash, firestorms ignite, tsunamis crash, and the sky fills with choking dust. Within a geological blink, 75% of all species on Earth are gone, including half of all plants.
Totally catastrophic. But in the aftermath, one unexpected survivor rises to take over in one of the most dramatic ecological reversals in history.
Most people think mammals were the winner of this big extinction jackpot.
Yeah, the rise of mammals, like us. Mammals for the win.
No. Actually, it was plants that had the first major comeback.
More specifically, ferns. Because scientists discovered something incredible in the fossil record. Before the asteroid, only about 20% of plant fossils were ferns.
But right after, 100%. Everything in the layer is ferns.
This is called a fern spike, a literal explosion of ferns taking over the planet. And it's not just the End-Cretaceous Extinction event where we see this. After other mass extinctions, after volcanic eruptions, ferns often recover first.
For example, after this 1980 Mount St. Helens eruption, ferns were found growing in mud just 2 months later.
So here's this humble houseplant surviving extinction after extinction for nearly 400 million years. But the real question is why?
Turns out scientists only recently decided to investigate this.
And what better way to study a mass extinction than to recreate one?
That sounds like a bad sci-fi movie plot waiting to happen, but okay.
Well, actually, it's incredibly easy to simulate a post-asteroid apocalyptic world. At least when you are studying plants in a greenhouse, it is. All you need is never-ending darkness and a lot of carbon dioxide and some acid rain and like really cold temperatures.
The cold is what concerns you the most?
I like my apocalypses cozy.
I think it'll be warm enough with that acid rain.
How cheery. You know what? It all actually just sounds really awful. Let's just agree, humanity, to try hard to not have an extinction level event anytime soon. Okay? Thanks.
Humanity's like, I got you.
Anyway, here's what the researchers found. Fern spores went dormant under the extreme conditions for like a few extra days, but once they eventually germinated, they thrived.
Thrived in an extinction level event?
Yep. The ferns in the worst conditions were actually less stressed than the ferns in the normal conditions. And I can't even keep mine alive in an actual house environment. So thumbs up if you've also killed your fern houseplant. You've never killed a fern. Did you kill my fern?
No.
She admitted it. Ferns have a number of adaptations that help them survive and thrive even in the worst circumstances.
First, their spores are tiny, smaller than dust, and capable of spreading across vast distances and lying dormant for decades.
Now second, they have major underground supports. Now everything that you know as a fern is actually a leaf, but their stems are all underground. Now these underground rhizomes act kind of like secret nuclear bunkers. They're just ready to sprout new growth even after massive surface destruction happens.
Ferns also aren't bothered by poor quality or high acidic soil. Some species can even help clean contaminated soil by absorbing heavy metals.
That's a major bonus.
Bonus time!
Bonus! And finally, ferns have special photoreceptors that allow photosynthesis in low light. All of these are adaptations that help them be the winning plants after the K-Pg extinction.
Okay, but how do we know these modern ferns will act like their ancient ancestors?
That is a great question, and researchers generally believe that the basic biology of ferns just hasn't changed that much since the Cretaceous.
So it's like Jurassic Park, but with plants?
Yeah, pretty much. And these experiments could actually teach us more than just ancient history. You see, understanding how ferns survived the K-Pg extinction could help NASA with something way more futuristic: terraforming Mars.
You know how long it takes a rocket to get to Mars? we gonna keep the fern watered and fed
Well,
that long?
well, not if I'm on the mission.
Hold on, are you telling me we might send ferns to be the first plant on Mars?
Yeah, if they could survive one of Earth's worst mass extinctions, they might actually stand a chance on the red planet, thriving in the deepest, darkest canyons we have in our solar system. Like this one.